You might have heard terms such as Renaissance, Baroque or Impressionism being used in relation to paintings, but what do they actually mean? Each of these represents a different artistic style, which refers not only to the time period in which an artwork was created but also to the defining characteristics of art from that period. Art historians look at the subject matter, color palette, tone, or brushwork style of a painting to determine which style it belongs to, but with more artworks being digitized than ever, they might need some help. We all know that computers are capable of a lot, but can they learn to accurately classify artistic style? As it turns out, yes, and it's all thanks to convolutional neural networks. Convolutional neural networks, or CNNs, are a type of deep learning model that can learn patterns and features from images by itself, as long as there is a substantial dataset of good quality to train on available. CNNs can learn the unique style of a painter like Van Gogh without the guidance of humans. The architecture of these networks is inspired by how the human brain processes visual information and consists of many layers that use mathematical operations to analyze the input image. There are three different types of layers in a CNN, namely, convolutional layers, pooling layers, and fully connected layers. A CNN can contain over 100 layers since these different types of layers can appear once or more often in the network. To make analysis possible, the image is converted to three tables of numbers, also known as matrices. Each pixel of the image is assigned three values based on its color, one for red, one for green and one for blue. A convolutional layer applies filters. During training, the filter slides over the input image and performs a multiplication of a value of the input image and a value of the filter. In this way, the model detects specific features, such as the intensity of the brushwork. After performing all these multiplications, the output of this convolutional layer is a feature map that is reduced in spatial dimensions by the following layer, the pooling layer. The pooling layer summarizes the features learned. By doing so, we save computing power and we improve the model's capacity to correctly classify unseen paintings after training, since only the important information remains. Finally, the fully connected layer uses all the extracted features to predict whether an unseen painting is Van Gogh or not. While there is still much work to do, these models can not only be powerful tools for museums and digital art archives but can also help make art more accessible to everyone.
Created using Powtoon.